Hello and welcome to the complete course of AWS SageMaker. In this lecture, we'll see how are we going to do an exploratory data analysis and try to understand the data set what we have, and then we are trying to split the data and put it into a local SageMaker instance, right? We'll put the data into a SageMaker instance and then finally upload it into an S3 bucket, and then finally from the S3 bucket we'll pull it and do the training. So let's get started with this. So we need to import a few libraries which would be required to do an exploratory data analysis. So for that we have imported the NumPy, pandas, matplotlib for the visualization, and then this register matplotlib converter will give a good visualization in a Jupyter notebook. So just select and click on it. So this got executed now. Once my libraries are imported, then we need to create a pandas data frame which contain all the features and the target variable. So here we have a train.csv which we have seen in the previous lectures, and then the date and time would be past state, and then the index column would be 0. So what we are going to do it, we'll just try to click on it and see over here what I'll do it. I'll just try to see how the data look like. So here we'll just try to see the first 10 records of the data frame. Here we can see over here what we have done it. This past data is created as an index now. So date and time is an index, and all the other feature would be treated as a column, and finally the target variable, the name of that particular feature is count, right? If I want to see the columns, what all the column we have, so we can see the date time is not a column now because it is an index. So season, holiday, working day, weather, temperature, rate temp, humidity, and a wind speed is a column. Okay. So I'll just try to see the length of the column. So I have 9 columns with me. Now if you wanted to see our data frames information, what kind of a data set you have, so whether any data set is having null data or not null, what kind of a data type each features has, so you can just write down that data frame name .info. So here once you click on info, it will give you features like we have a season. The season is, so if you'll see, we don't have any not null value, right? And here we have total 10,886 records, and this particular feature is of type int64. We have a temperature and ctemp which has a float 64 features, and finally the count would be the int type, right? So it is a continuous variable. So now once that is done, now the second part is you need to understand the data frame what we have. So we'll just do the describe and try to understand each feature. So features is a column over here, and in the row you can see what each features is having a different statistics. So for season I have a count 10,886. The mean value is 2.5, standard is deviation is 1.16, minimum value is 1, my maximum value is 4. So this means for a season I have a minimum and maximum value as 4. Similarly, in case of a temperature, if you see, the minimum temperature is 0.82 till 41 degrees Celsius, right? And if you see the count, the number of bike rent, the minimum number is 1. So here each hour we have at least 1 bike sold, and the maximum bike sold for that particular hour is 977, right? Now in case of a AWS SageMaker, we need to understand that my target variable would always be considered as a first row, or sorry, would be considered it as a first column. So that is the reason here what I did it, I have done this target variable count as a first place with the subsequent independent features, right? So once I click on this and try to shuffle, so in this case if I'll again show, I'll do df train at height, and you can see my target feature. So my target feature is at a first place, right, followed by the independent features, correct. Now the second part, we need to understand that date time is also a very important feature, right, since we have already made this as an index. However, there might be the chance my bike rent frequency is low in the afternoon. However, in a morning and in an evening, my bike rent frequency is more. So that at which particular hour my bike is getting rented is also a very important features. So that is the reason we are trying to increase the number of columns, or we can say we are doing a feature engineering wherein we are trying to increase or add the columns based on the data set what we have. We are deriving it from the existing features. So what are we going to do it? For this particular year, we are trying to split this date time into year, month, day, day of week and hour. So I would like to just execute this and showcase here, right. So if you see here, my year, month, day and date, time and hour would now be the feature of this data frame, correct. Previously I have 9 features, but now if I'll see and calculate the number of features we have, so what we need to do it over here, I'll just add a cell and try to find out the length of TF column, correct. If I need to understand how many columns we have now from 9 column we have converted, or we have increased the column from the derived features as a 14 column. Now we are trying to do another or a different kind of a feature engineering. Till now you have learned how to normalize or standardize your independent features. Now see how to normalize your target variable, right. So here if I go up, scroll up and see here, my count, the number of account, minimum number of account of a bike which was rented was 1 and the maximum is 977. So this means my data is dispersed a lot, right. So to normalize and make it into a small scale, what are we going to do it? We are having another features in doing while doing the feature engineering is taking a log. So what log does it? It converts the high dimensional data set into a small data set, into a small scale. So what I'll try to do it, I'll just show you here. So if I'll take a np log 1p and take a value of 2.63309, right. So my larger value of 13 is become 2.6, that is at a lower scale. Now if I can take an exponential of this value 2.63, right. So after taking a log we have an exponential value. So for while taking an exponential value, what will happen, the smaller scales will become, it comes into a larger scales, right. So when we are doing a prediction, because we already have taken a log, so my prediction will also come at a lower scale, and while doing the exponential of it, it will come into an original scale, right. So once that is done, so how are we doing it, how are we do this? We will do this by doing a map function here, and if I'll do a head, you can see here my all large scale data set has been converted into a small data set, right. Now again we'll do the describe. My minimum value is 0.69 and my maximum is 6.88 out of count. So once this is done, what we need to do it, we need to shuffle this data set, right. So what I'll going to do it, I'll just take an index. So sorry, so here after taking a describe, I'll just list down my index value. My index value is a timestamp, right. So here I'll just print it out over here. So if I'll execute this L, here I can see the timestamp for each hour, right. And now what I'm going to do it, I'll just shuffle it, and once the shuffle, I'll just do the delog so that my whole data set will get shuffled. So here I can see my data set is shuffled now. Now you can see the second R details would be mentioned at the top, and first R detail is mentioned at a random value, at a random position. Now once that is done, I'll just try to take a shape and see how many column we have and what kind of a data set we have. So we have 10,886 rows and 14 columns, right? So till now what we have done it, we have learned more about a sklearn, train and split, right? So in a subsequent lecture or for a subsequent different use cases, we'll also use the train split. But there are another method also which is widely used, at least in case of a BFSI, wherein we are not trying to do a train split, we are just trying to do a split based on the simple method. So what is that method? So to make you learn that method as well, so I am trying to split the data by explicitly mention the numbers, right? So here what I am doing it, I'll divide the data into 75 and 25%. So what I'll do it, I'll take a 75% of my shape, that is 75% of 10,886, right? So that comes to 800 and 164. I'll just enlarge this. And now the remaining test data set would be df train minus train number. So here my test number would be 27005, right? And these are the column what I have. So what I need to do it here, the data frame dot iloc from all the columns till train number. So top 800 and 164 data set would be taken up first, and that we will take it as a train data, that is a linear regression train.csv, and we will convert it into a CSV, right? Similarly, for a testing data set, what we are going to do it here, we'll see from this 864 till remaining data, we will take it as a test data set. So here I'll execute both, right? So this is what we have. Now what we have already shown it, see this is a train data set and this is a test data set, but we have also a validation data set. We have already explained that in initially first 19 days of the particular month would be considered as a training and remaining days would be considered as a testing part, right? So for that we will again try to do all the feature engineering or all the analysis what we did it for the train, we will do it for the testing as well. So the next step we did it, we have splitted this date time into an year, hours, day of weeks and a day, right? So the similarly we'll be doing it over here, and once that is done, yeah, this is done, we are saving it into a LR validate data set, right? So that LR val is for the validation. So here I'll do this, I'll show it over here. This data set we would be using it for the prediction because we don't have a count, right? So in a next lecture we will see how to train a model on SageMaker using a linear regression. Thank you.